Ladies and gentlemen, good morning. First of all, let me thank you all for being here on the second day in our conference, which is the second conference on science, on applied science and engineering. Today we are here to attend the first plenary given by Dr. Abdellah Draidi, which is entitled Industry 4.5 Challenges and Perspective. You have the word, myself, to present your work.
Thank you, sir, for your honor. Welcome to my presentation. It is entitled Industry 4.1 Challenges and Perspectives. My presentation will have 6 parts: introduction, history of industry, Industry 4.0, Industry 4.1, perspectives, Industry 5.1, and the case study in our institute. Introduction: humans have been evolving their techniques and methods of manufacturing and producing goods and artifacts from the first wheel to the aircraft. Scientists has divided this evolution into 4 major industrial evolutions. History of industry. The first industrial revolution was characterized by mechanization, steam power, and of course a factory system. 100 years later came the second industrial revolution, which is characterized by the invention of electricity and electricity which had opened the door to communication, telegraph, telephone, internal combustion engine, and mass production and assembly lines. 100 years later came the digital revolution, which is Industry 3.0, which is characterized by computerization and of course automation, electronics, and PLCs. Nowadays we are living in the 4th industrial revolution. We will begin by Industry 4.0. The need of Industry 4.0 is to convert the regular machines to self-aware and self-learning machines to improve their overall performance and maintenance management with the surrounding interaction. Industry 4.0 aims at the construction of an open smart manufacturing platform for industrial networked information applications. Industry 4.0 can be defined as the integration of intelligent digital technologies into manufacturing and industrial processes. It encompasses a set of technologies that include industrial IoT networks, AI, big data, robotics, and automation. Industry 4.0 allows for smart manufacturing and the creation of intelligent factories. So there has been a paradigm shift from Industry 4.0 to Industry 4.1. Industry 4.1 represents the evolution of Industry 4.0 with key drivers like hyperconnectivity and real-time data exchange, smart maintenance and zero-defect objectives, human-machine collaboration, sustainability and circular economy, digital twins and predictive maintenance, and cyber-physical resilience. This industry will face major challenges like cybersecurity and data integrity, workforce upskilling, workers they will be updated, interoperability across legacy systems. We have legacy systems and new systems. Ethical and regulatory concerns, especially with the introduction of AI, and the high initial investment. Key technologies driving Industry 4.1. Industry 4.1 applies edge and cloud integration, real-time data processing, and scalable analytics, AI and machine learning, predictive maintenance, adaptive control systems, cyber-physical systems, seamless interaction between digital and physical components. Of course, a cyber-security framework ensuring data integrity and system resilience. And finally, advanced connectivity, which is the key feature of Industry 4.1, with 5G, mesh Wi-Fi, OPC UA, web servers, and robust communication. As academic or for university, we have perspectives and we have duties to allow to be integrated with industry, fourth generation of industry. We must have interdisciplinary learning, like integration of automation, data science, etc., cybersecurity. We must have hands-on training platform, the use of multiple software, hardware, like ONCC Unified, here, Portal, etc. Project-based learning. We have to encourage innovation, teamwork, tutorial project tutorial, and problem solving aligning with industrial scenarios. Global standard alignment, we have to be aligned with ISO and other industry frameworks. And finally, we must have continuous curriculum updates. We have to update our program in university. Strategic response, in the other hand, with institutions like industry, we must have academic and industrial collaboration, real collaboration between university and the factory. And policy and government support, we must have government support and investment support. We must have data-driven decision making and sustainability and quality integration. So what is Industry 5.0? It is a new paradigm. Industry 5.0 is the next evolution of industrial development, focused on human-centric, sustainable and resilient production. And like Industry 4.0, which emphasizes on automation, AI and efficiency, Industry 5.0 integrates human creativity and collaboration with advanced technologies to create value beyond productivity and profit. So we can say Industry 4.0 is not an evolution of or replacement of Industry 4.0, but an awareness of its trajectory. Characteristics of Industry 4.0, we have sustainability, production system based on renewable energy, a goal reduce carbon emission by 55% by the 2030 Euro target, circular process, circular economy, reuse, recycle, minimize waste, respect planetary limits, human-centric, humans at the center of production, technology serves people, not the reverse, protect fundamental rights, privacy, autonomy, dignity. As a resilience, ability to adapt to crisis, COVID-19 for instance, geographical shifts, natural disasters, and ensures industries remain robust under adverse conditions. So for the case study, we have taken our Institute of Applied and Technology or Techniques, and competence outcomes. Students demonstrate readiness in smart automation, data-driven decision-making, and secure system deployment. The second competency is projects serve as pilot-ready prototypes for industrial partners. So we have taken tutorial project and final year project tutorial here. I have taken some examples. For this example, we have the implementation of Siemens thematic PLC networks S7 1200, Logo 8, a VFD MicroMaster supervised by WinCC Unified. So in this project, the students have divided work into 3 levels of automation. Field level with a VFD induction motor and an encoder for feedback. On the other hand, we have a stepper motor driven by a driver. In the control level, we have a S7 1200 and logo, 2 PLCs that control the 2 systems above. Above we have supervision, which is assured by UNCC Unified, and the switch, of course. The second project is the design and construction of honey production line. This project is divided into 3 parts: mechanical parts with a conveyor and the honey extractor, the electric part with the electric cabinet, which have electric components, and the automation part with the PLC, a router, an HMI, and PC station. As for final year project, I have taken this project, the design of an automated electric forklift chariot for a palletizer, chariot palletizer. So the students here have programmed a new interface and have automated the chariot forklift for the movement of in cement company. The second part of this final year project is the smart stock. Okay, they have integrated AI for this forklift to be smart enough to have to stock cement. The second final year project is improvement of, in the cement company also, improvement of clinker stock management. In the whole of clinker, the students have automated the system. They have made the necessary approach for automation of clinker management. Of course, with Siemens. The final example is the development of a supervision system at pharmaceutical manufacturing company. It was a real system with the students of master, which students here take all of the sensors and actuators and program the system, or the whole system, and have made the supervision system by UNCC Unified. As for the administration, we have made the program offering of an academic master, professional master. Professional master program, automation of industrial electrical-mechanical systems. This new master is on course, okay, which represents the second master of the Department of Electromechanical. And finally, thank you for your attention.
Okay, thank you very much indeed for this presentation that contains that kind of information, especially that our university is considered in this stage of technology, which is the 4th generation of technology. Besides to that our university is one of the first university in our country that try to achieve that stage of technology. Thank you again for your presentation. Now we achieved the question section. So I'm asking the audience if there is any question. They are welcome to give their questions. Even for our students, you are welcome. to ask questions on our experts. Yes.
So, thank you very much for your presentation, Mr. Draidi. My question is focused about, you have said in your presentation that there is, in your perspective, is to achieve the industry 4.0. What is the difference between what we have done in our program and the objective or the aims to achieve the industry of 5.0? And
thank you, Mr. Asaba. Do you mean about our new master?
Yes. Yes.
To achieve 5.0?
Of course.
Our new master is, we can class it in the fourth industrial revolution, 4.0 to 4.0. To achieve 5.0, we can say, je peux dire en français, c'est un savoir-faire, savoir-être. Industrie 5.0, c'est un savoir-être. C'est pas un savoir-faire. Donc, l'industrie 4.0, it comes to correct the trajectory of industry of the fourth industrial revolution. So, as we can say now, we can see now the fourth industrial revolution has taken the trajectory for the AI
as tools that we have to use in Industry 4.0, according to 4.1, for example.
The difference between 5 and
what the means, what we should do, that we should be used to know the difference between these two technologies.
I can give you an example for to achieve Industry 4.5.0. We must add transversal units that take part of human-centric sustainability, resilient, etc. For example, we can add modules, matière, like circular economy circulaire, c'est-à-dire tout ce qui est énergie, tout ce qui est recyclage, etc. Circular processes. As you know in ISTA, the programs of ISTA are based on the collaboration with the European Union. For the European Union, the programs are already aligned with 4.0. Les anciens programmes sont déjà en concordance avec 4.0, l'enseignement ou l'industrie. For example, like we can say matière PPP. PPP, on a déjà le PPP, on a enseigné, peut-être on va faire de nouveaux programmes actuellement, peut-être 2025, on va nous aider au PPP. On a fait 2015, 2016 ans. C'est un exemple.
Salam alaikum. Donc je vous remercie Monsieur Draidi pour la présentation. C'est une présentation très importante. C'est-à-dire normalement les étudiants, c'est-à-dire de l'Institut des sciences et techniques appliquées et économiques à Lyon, d'accord. Voilà. Trois étudiants surtout. Vous tous. Voilà, d'accord. Ouais. Donc, Abdellah, c'est-à-dire, j'ai une seule question, d'accord? C'est-à-dire comment passer, ou bien quels sont les éléments d'abord essentiels pour passer de l'industrie 4.0 vers l'industrie 4.1. D'accord? Parce que d'accord, c'est-à-dire actuellement, c'est-à-dire chez nous en Algérie, la majorité des entreprises, d'accord, c'est-à-dire كما نقولوا راها في l'industrie 4.0 et أقل من l'industrie 4.0. Exactement, 3.0 et 4.0. Mais actuellement, c'est-à-dire au niveau de l'Europe, ou bien, c'est-à-dire, c'est-à-dire, exactement, c'est-à-dire هم les Européens, donc actuellement, راهم دخلوا في l'industrie 4.1. 4.1. Donc, c'est-à-dire, واضح لنا برك les éléments principaux, c'est-à-dire اللي نقدروا نديروا بينهم passerelle من l'industrie 4.0 للindustrie 4.1. شكرا.
Mr. Abdellah. Je peux vous répondre en français. Les deux éléments clés, c'est des éléments AI and machine learning. Advanced connectivity. Il y a le shift entre 4.0 et 4.1. Donc déjà l'automatisation arrive 4.0. L'industrie 4.0, déjà on parlait de l'automatisation et de production, etc. Mais quand est-ce qu'on parle de l'industrie 4.1? Lorsqu'il y a AI, intelligence artificielle, machine learning, ou avec advanced connectivity, un réseau de connexion, de communication moderne, 5G, mesh Wi-Fi, surtout dans le cas de l'ETP, les masters, le OPCUA, le web server. Où il y a des étudiants qui m'ont il a pu communiquer avec la communication de l'industrie pharmaceutique, entre l'industrie pharmaceutique et la France ou l'Algérie, de la communication de l'OPCUA. Donc, le manager français est intervenu dans un problème au niveau des automates de l'Algérie, au niveau de l'Algérie. C'est un exemple. هذه عليها قدرت نقول لكم اللي دخلنا في 4.1. Donc for the shift to the 5.0, we must have a human-centric. What does it mean, human-centric? We must put our conscience and correct the trajectory of the industry. Because the industry 4.1 is predatory. You can say predatory study. That means it have AI, connectivity, etc. And if we don't correct the trajectory, we should face a lot of problems.
Donc,
juste pour une remarque concernant si les autoroutes renouvelables utilisées actuellement au niveau de l'industrie algérienne. C'est-à-dire, c'est-à-dire que nous la cybersécurité. Voilà, la cybersécurité, ما تقدرش تبروجي les entreprises تاعك les chaînes de production تاعك avec les automates 1200 qui ne peut pas. Il faut utiliser les automates 1500, d'accord, 1500, c'est-à-dire وين تقدر تبروجي les chaînes pour c'est-à-dire كيما نقولوا c'est-à-dire باش تحمي toutes les chaînes de production تاعك. D'accord. Voilà, contre la cybersécurité, parce que les gens يقدروا يعطيوك d'accord sur internet وين يحبسوا toutes les chaînes de production تاعك. Donc هذه c'est une remarque بركا, c'est-à-dire باش اللي يخدم c'est-à-dire l'intelligence artificielle, c'est-à-dire pour les chaînes de production, il faut utiliser les automates programmables 1500. Il ne faut pas utiliser les automates programmables 1200. Et merci beaucoup.
Je vous remercie, M. Boucher. Et je rajoute à votre remarque, on a fait visiter la société Naftal, ça fait 15 jours. La société Naftal, côté GTL, gaz liquéfié, ils vont rénover tout leur système d'automatisation. Moi, quand j'ai le S7-200, safety control, automate de sécurité. Le 200 c'est obsolète. Moi, ils vont déjà dans le marché, mais Siemens ou ma Schneider. Schneider, tu as des armoires, tout ce qui est armoire électrique, etc. L'automatisation ou le SCADA, tu as Siemens. C'est un méga projet, il y a pour le GPL.
Thank you very much. Any other questions? Any other questions? Otherwise, I take chance to ask questions if you don't mind. So, what do you think about the role of University of Algerian universities in achieving this kind of technology? Otherwise, maybe on the other hand, if I can use the word, can we apply the industrial technology 4.5 in other fields of specialties, maybe in law, for example, in biology? What are the challenges in applying this kind of technology in these fields of specialty? Thank you.
Yes, you're welcome, Mr. Hussein. I can take the second question. Here we have an example of technical this 5.4.1. Donc il y a c'est-à-dire la quatrième génération de l'enseignement. Donc le terme 4.0, the term it was introduced primarily for industry 4.0. Then this term was taken to all the fields like communication, university, etc. So for the first question, to answer your first question, I can give my institute, our institute, ISTA. It is an example c'est un exemple تاع الإرادة. باش تقدر ديجا مشينا في 4.1 قادرين نروحوا حتى ل 5.0 avec peu de moyens. وش باش قدرنا نوصلوا لهذا النقطة هذه. دونك لازم تكون عندك الإرادة وتكون بيروقراطية. Tout simplement. We have an example. Is it a real example? So we invite all the departments, all the faculties, or all the universities to take our project.
Our example.
For example.
Yeah, thank you very much.
You're welcome.
Yeah, you can have the word. Yeah, no problem. We have a student in our institute. Maybe he has a question. Yeah, welcome.
Yes, please.
السلام عليكم. حاب نجاوب على السؤال تاعو برك. عندي واحد الاشكال كبير واللي هي الانفورماسيون اللي غلاك المجال هذا في الجزائر حتى تسمى شغل باش تتعلم حاجه كيما هذه في البلاصه هذه في الجزائر تلقى صعوبات، صعوبات من حيث التعلم، صعوبات من حيث الأدب، صعوبات من حيث المعلومات اللي نجيبوهم. حابنا شغل نستفسر اسكو نلقاو بلايص نتعلموا منهم الحوايج هذا.
نشكرك على الطلب. كاين دي سونتر دو فورماسيون بريفي. البريفي ما عندكش يديك فورماسيون اكسيليري تاع سيمين دو سيمين تروح. باغ كونتر هنا كيما جربت في الانستيتيو تاعنا كاين لونسينيمون دي بازي سور 60% دو براتيك. طرابو براتيك لي ستاج اكسيتيرا. دونك لازم تكون ديجا لا فورماسيون لا ديري تكون شويه اسي لونغ باش تقدر 3 ans حتى 5 ans. بيان سور كيما قلت قبيل الاستاذ الاراده تاع المسؤولين باش يجيبوكم ماتريال باش يجيو في ستاج اكسيتيرا. وكاين اللي يشتغل خلاص باش تجيب لو ماتريال كيكون 10 مليار باش تجري على ستاج اللي وين درك في الاندستري عاد صعيب بزاف باش يخدموا لنا لي ستوديون. دونك كاين لي سونتر دو فورماسيون لي زونيفرسيتي اكسيتيرا. دونك تما راك ديجا في ليستا راك في بلاصه فيها نقدر نقول لك ماشي هذه نشطب ليها هذه سي رياليتي. قدرت الانستيتيو راهو افونسا بزاف في الدومين سيتو في الالكترونيك في الديبارتمون تاعنا. ونقدر هنا قدرت نقول باللي رانا مشينا ل 4.1 اندستري 4.1.
Okay, thank you very much. Maybe we have the chance for a last question before to move to the oral session. Are there any questions? No questions? Okay, again, Mr. Draidi, Abdellah, thank you very much for this valuable presentation, which is entitled Industry 4.1 Challenges and Perspective. Now we have pleasure to move to the oral session for the topic 4. Thank you very much again.
Okay,
Thank you.
sir.
Thank you.
You're welcome.